Hi friends and my dear students. Today 12th Physics 8.33 Bohr Atom Model. Last class we have seen the hypothesis of the Bohr. Today we are going to see radius of the orbit of an electron and velocity of the electron. Very important 5 more questions. For that we have to assume an atom. We have to assume an atom. The center is considered to be a nucleus of Z proton. Atomic number is considered to be Z, and the charge of the proton is said to be E. This one nucleus is considered to be as a rest. Nucleus is considered to be at a rest or at a stationary position. Now, the total charge of the nucleus is considered to be plus Zg, whereas you have to consider the velocity of the electron as said to be Vn, and radius of this electron are said to be Rn, and the mass of the electron are said to be m. These are all assumption value. Now, and because of the electrostatic acceleration provides the centrifugal force of an electron towards the nucleus. This is the force which is due to the electrostatic attraction of the nucleus for the electron acts towards the nucleus. These are all assumptions that we have to make to identify or to calculate the orbit of the electron and the velocity of the electron. Now, let you imagine when the electron are continuously revolving in the orbit with the radius of Rn and velocity of Vn, then we can write as well the Coulomb's law of attraction. F is proportional to, if you consider two charges Q1 and Q2, then the product of this Q1 and Q2 by R square are equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, that we already studied in the previous chapter. In the same manner, here we have to find out F, the force due to Coulomb force, due to the Coulomb force. Coulomb forces is equal to Z E square, center of the nucleus charge, and the charge of the electron is said to be minus E. Therefore, minus E divided by 4 pi epsilon naught Rn square. Or you have to minus Ze into minus E. Ze square minus Ze square divided by 4 pi epsilon naught Rn square. This is the forces of attraction of the electrostatic force attraction by the nucleus on an electron. This is the equation. Another thing, the same electrostatic force provides the necessary centrifugal force of an electron. This electrostatic force also gives an force to the electron towards the centrifugal force. Therefore, we can write F vector. F is the force due to the centrifugal force, that is equal of mg square that is equal to mv square by r. M v square, here vn square by rn. Here we are putting r cap. Here we are putting r cap because both here we are adding r cap for the purpose of unit vector. This cap, it is called one cap. We are not putting one cap, that is r value is equal to unit vector. That's why this gives only direction, there is no magnitude value. You can understand these things. This is very important concept. If the force of attraction by the is equal to the centrifugal force mvn square by rn, that is nothing but centrifugal force of attraction. Centrifugal force of an attraction mvn square by rn. Now we can imagine, we can find out, or we can find the, we have to assume that the mass of the electron is said to be m and the mass of velocity of the electron vn and Planck constant as h. Then we can write the modulus value of m f vector Coulomb. Mod value is equal to mod value of f vector and due to the centrifugal force. This is the force due to Coulomb's attractive force. This is the force due to the centrifugal force. Both are equal only in magnitude. Therefore, we can substitute this value only in magnitude, not in the direction. That's the meaning of this mod value. We can consider here the magnitude alone. We are not bothering about r cap or minus, whatever it may be. Now, we have to z e square divided by 4 pi epsilon naught rn square, that is equal m vn square by rn. Okay, are clear? Now we want to find the value of rn itself. For that I have to simplify this equation with a small step. One thing we have to assume that we have to bring this r1 to the left hand side or rn square to the right hand side, remaining all. This must be to the downwards and this must be in the upwards. Therefore, rn that's equal. First you have to, already we have vn square, then rn square, and then divided by into 4 pi epsilon naught, divided by z e square. Are you clear? Z e square. Now I want to make, last class we already studied the angular momentum L, that is equal to nh by 2 pi or nh bar. We already explained in the last class, the angular momentum of electron is the multiple values of h by 2 or h bar is nothing but h by 2 pi. That's why I can multiply the m square then by m. That is 1 m are cancelled, then again v. M square, vn square, v velocity, n square, rn square, 4 pi epsilon naught divided by z e square. So that we can write Rn is nothing but m Vn Rn whole square. m Vn Rn whole square into 4 pi epsilon naught. 4 pi epsilon naught divided by m z e square. m z e square. Instead of this value, you have to write nh by 2 pi. nh by 2 pi. That's a very important approach. Or you can straight away put the value of h bar, also like h bar. But here I have to write only nh bar. That's equal nh bar whole square equal 4 pi epsilon naught divided by m z e square. Are you clear? This is the radius of this value. In this term, we have only the value of 4 pi epsilon naught n h bar square divided by z m e square. Are you clear? Or you have to modify 4 pi epsilon naught n square h bar square divided by m z e square. This is the value of Rn. Now I want to minimize this equation according to the, or you have to put the h bar is nothing but h by 2 pi. If you want to put instead of h bar, you have to put the h square by 2 pi square, whatever it may be, as you like. Now I want to put the value of h bar as in the form of h by 2 pi. Then what will be happen? 4 pi epsilon naught n square h square. Instead of h square, you have to put h square divided by 4 pi square, whole thing divided by m z e square. Here 4 pi cancel. Then remaining that n square h square epsilon naught divided by z. There will be 1 pi. Here 1 pi is missing. Where we are missing 1 pi. Pi. Here is 1 pi. Remaining 1 pi is here. So that we have to write this pi will become here. Therefore n square h square epsilon naught pi m z e square. This is the final equation. For the radius of an atom. This is the final equation of the radius of an electron. Now I have to modify this equation for our convenience. What is the value of Rn? Rn is nothing but n square h square epsilon naught divided by pi m z e square. Here n square and z is constant. Therefore Rn become n square and z is constant. Remaining value is all known values. So substitute the value of Planck constant, mu bar epsilon naught pi m e square value, then we have to consider as a naught. Since a naught is nothing but except n square z, then we have to remain all those things. H square epsilon naught divided by, instead of z, pi m e square. This is the value of a naught value. This is called Bohr radius. Bohr radius. This is called Bohr radius. Bohr radius. What is Bohr radius? This is the fundamental equation for the lowest atom. When you consider the lowest atom, this is the fundamental equation to identify the lowest energy radius of an atom. It is called Bohr's radius. This is called Bohr's radius. Are you clear? Now, if you want to explain one Bohr's radius or anything else, if you want to find out the value of a naught, then a naught, that is equal nothing but h square epsilon naught divided by pi m e square. This is called Bohr's radius, and the value of this one is equal to 0.529 Armstrong. This is the basic value that we are obtained for Bohr radius, which is the smallest radius of the orbit in an atom. Bohr radius is also used to as unit length of called Bohr. One Bohr is equivalent to 0.529 Armstrong or 0.53 Armstrong. This is the value of one more question. One Bohr, that's equal to how much Armstrong value? This is one of the very good equation. When you consider hydrogen atom, for hydrogen atom, Z equal to 1. When you consider hydrogen atom, Z equal to 1. Therefore, we can substitute the radius of the nth orbit of an electron. The radius of the nth orbit of an electron, Rn, that is equal Z equal to 1. Therefore, A naught into n square. This is the fundamental equation. When you say the lowest orbit called n1, then what will be the value? R1 equal A naught into 1 square. That's equal to A naught. What is the A naught value? We already determined, that is 529 Armstrong. This is the first orbital value. If you want to find out R2, n equal to 2, then you have to find out R2, A naught equal to 2 square, that is nothing but 0.529 Armstrong multiplied by 4, that is equal 4 A naught or 4 into 0.529. This is equal to 2.116 Armstrong. Likewise, if you want to find out the value of 3 square, then 9 A naught. That means 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25. Likewise, you have to go on until up to that Rn value, so that 0.529, and substituting multiplication of 9, then we get 4.761 Armstrong. This is the value of R3. Likewise, if you are increasing the value of n, then we concluded that Rn here is depend on only n. These are all constant. Therefore, Rn is proportional to n square. That means, this is a final equation we obtained to explain the radius of the orbit from the center increases with n. The radius of the center with increase in the proportion of n square. That's the thing that we are obtained here. That's our first equation for radius of an electron. Right. The next one, we are going to derive an expression for velocity. We have to find the velocity equation. For that, we know the value of mvn Rn, that is equal here Rn equal A0 into n square. Rn, that is equal A0 into n square. Substitute this value, then mvn A0 n square. Are you clear? Right. So mvn Rn, that is equal, it is nothing but, here already you know the value of z also. Z means n square by z. That's why we have to put the value of z. In your textbook, I think in page number 151, there was a mistake in your textbook. 151, the last column, nearby the figure, the equation given mvn A0 n square, but that is wrong. You have to divide by z itself, because Rn value is nothing but A0 n square by z. Now simplify this equation. We obtain the value of velocity of the n, Vn, that is equal to nh by 2 pi. This was already explained in the last class. This is nothing but angular momentum of an electron is multiple values of h by 2 pi. That's why we can write these two things. The things are these equations. Therefore, Vn equal Vn. You have to consider Vn itself. Then remaining all you have to bring that side. Then nh by 2 pi divided by m A0 into n square into multiplied by z. One n is cancelled. Therefore, h is divided by 2 pi m A0. Here in this equation, z by n, here one, we are missing one n. n square is cancelled, remaining n is here. H is at 2 pi m a naught n. 2 pi m a naught n. Okay. Now we have to explain like this: h pi 2 pi m a naught z by n. Z by n. So that we can write the velocity of the equation is directly proportional to 1 by n. Remaining this all value is a constant. These are all constant. That is, when you increase the orbital value, the velocity which will be decreased. When you increase the orbital value n equal to 2, then the velocity which will be decreased. Velocity will be decreased, whereas the radius which will be increased, here the velocity may be decreased. That's a very important relationship between the velocity and radius. That's the thing that we have to explain with the help of some graphical representation as shown in the figure. If you consider velocity in y-axis, velocity in the y-axis, velocity in the y-axis, velocity in y-axis, and we have to consider n value in the x-axis. The graph is in the as shown in the figure. This graphical rectangular hyperbola. This is called rectangular hyperbola. This rectangular hyperbola indicates that Vn is proportional to 1 by n. That is, when you increase the value of n, the value of mu n which will be decreased as shown in the graph. If suppose value is n is decreased, then the higher velocity. When n is increased, the velocity will become low. Furthermore, if you are increasing the n value, again the Vn is decreased. That is a fundamental graph. Rectangular hyperbola shows that when you increase the value of orbital quantum number, then the velocity of the electron which will be decreased. This is a very, very important concept that we already studied about according to Bohr's atom model. It was explained by Rn as well as Vn. That's a famous equation that you have to understand clearly. Yes, that's why you have to. I have to give separately the radius of an electron and velocity of the electron in the first clearly. Then next we are going to derive an expression for the energy equation, energy of an electron while rotating in the orbit. That's an important concept that we are going to see in the next classes. Here, when you say Rn value, when you say the Rn value, it is, then we have to memorize it value. N square, h square, epsilon naught divided by pi m z e square. This is the basic equation that you need to calculate. If you want to find out the value of R1, R2, R3, R4, whatever it may be, this is the basic equation that you need to calculate all these values, and it is very important for 1 mark and 3 mark sums also. So I hope you may understand clearly all the steps that I was explained now. Thank you, my friends.